Here is the homework to review for the quest we're going to be taking. So if you know how to do all these problems, you should be very well off for your quest. Okay, you should do fine. All right, so the square root of a negative number is going to be imaginary, so we know it's going to be I. And we also know it's negative, right? Okay, so this negative is the I. And the square root of 400 is 20. Okay, when you're adding together here, we're looking for like terms. So 3 plus 4 is 7. And 2i minus plus a negative 3i would be negative I. With this, my suggestion would be to take this negative and distribute it through just so you don't forget to subtract the 4. So it would be negative 3 minus 4i, positive 2 minus I. Okay, now you can look for those like terms. So 2 minus 3 is negative 1, plus 2 would be 1. And then negative 5 and negative 4 would be negative 9, minus 1 more would be negative 10i. So 1 minus 10i. Okay, next one was number 57. Okay, so once again, I suggest you take through that negative, be negative 2 minus 3i, and that's a positive, so this will just stay the same. Then just add your like terms. Negative 4 plus 2 is negative 6. Negative 4 more would be negative 10. Negative I, negative 3 would be negative 4. Plus 5 would be plus 1i. Number 63. We're now multiplying. 3 plus I times negative 3 minus I. Okay, so we're going to distribute everything through. 3 times negative 3 is negative 9. Negative 3i, negative 3i, negative I squared. Okay, and remember that I squared is equal to negative 1. Okay, so this makes this a negative 1, which makes it a plus 1. Adding to that makes it negative 8 minus 6i. Number 69. Okay, if you remember, squared means times itself. So this would be 3i times 2 minus I times 2 minus I. It wouldn't matter which way you do it. I tend to want to do these together first before I distribute that I through, so that I'm going to do it that way. But you don't have to. So it would be minus 2i minus 2i plus I squared. Okay, I squared is negative 1, so it would be 4 minus 1 would be 3 minus 4i. And we have to take that times this 3i yet, which makes 9i minus 12i squared. Okay, now, usually we put the number first. Okay, so I squared, negative 12 times negative 1 makes 12. And then we have plus 9i is our answer. Number 73. Okay, we have I to the 5th. Okay, if you remember, we want to try and see how many I squareds we can get out of it. So to make it an I squared, we got to do this. So this would be I squared would be out of the 4th. This is negative 1 squared, which would be 1, times I, which is I. 75, I to the 15th. Okay, I can't say how many I squareds there are there yet, so I have to take an I out first. And then I have 14 left. And then this one, I can say this is I squared to the 7th power. I squared, once again, is negative 1. Negative 1 to the 7th power is negative 1 times I, which is negative I. Number 77 is I to the 64th. Okay, notice I don't have to take an I out like I did here. I can just go right to, this is I squared to the 32nd. So we have negative 1 to the 32nd, which is 1. (103) we have 4 minus 3i divided by 4 plus 3i. Okay, so remember with these problems, we don't like the I in the denominator, so we're going to multiply by the conjugate, which would be 4 minus 3i. And when I do the bottom, I do the top because it's like multiplying by 1, right? Okay, so if I multiply this together, it'd be 16 minus 12i minus 12i and plus 9i squared. 16 minus 12i plus 12i minus 9i squared. Okay, we simplify it. On the top here, I squared is negative 1. Negative 1 times 9 is negative 9. So 16 minus 9 would be 7. And then minus 24i. And on the bottom, this would be plus 9. So 16 plus 9, because it's negative 1, and these middle terms cancel out, would give you 25. And then you look, does anything divide out of all terms? Nope. So that's our answer there. Okay, if we go to page 175, we want to do number 6 here, put it in vertex form. Okay, so using completing the square to put it in vertex form, okay, we're going to take this 15 to the other side. And then we have to complete our square. Okay, so what's going to complete the square here? Half of 2 is 1. 1 squared is 1. So we're going to add 1 to both sides. So on this side I have p of x plus 16. And over here I have x plus 1 squared. Lastly, to put it in vertex form, p of x is equal to x plus 1 squared, and then we subtract that 16 over the other side. So if you want to know the vertex, we know the vertex goes down 16, and it goes this way 1. So our vertex is at the point negative 1, negative 16. Okay. I want you to do the same thing with number 16. Which is p of x is equal to 4x squared plus 3x minus 1. Now, this one's a little tougher because we got a 4x squared there, so we're going to have to deal with some fractions, okay? But first thing, let's divide everything by 4. So it'll be 3/4 x and minus 1/4. Okay, we can take this 1/4 over. You really could have done that first as well. So we're going to add it over to this side. Okay, now we want to take 3/4 and we're going to divide it by 2, which would be 3/8, and we want to square that, which would be 9/64. Okay, so if I do this in our heads here, 3/4 divided by 2 would be like half of it, would be 3/8. And if I square the 3, I get 9. Square the 8, I get 64. So you get 9/64 to complete the square. Okay? So here, this would be p of x over 4. Okay, 64's, so this would be 16/64. 16 plus 9 would be 25/64. And over here, this would be x, and half of this was 3/8. Okay. Lastly, we want to bring this over. And multiply it all by 4. Okay, and if I take 25 over 64 and I multiply that by 4, I get 25/16. Okay, so there I have my vertex. Okay, vertex will be negative 3/8 and negative 25/16. Okay, so be able to use completing the square for those there. If we go to page 189, okay, number 16, we want to use the square root method for. Two x squared equals 48. Okay, so to solve this using the square root method, okay, so we're going to use the square root method. We're going to get the x squared by itself first. So divide that would be 24. And then we want to take the square root of both sides. X equals plus or minus the square root of 24. Okay, now I want to simplify that, square root of 24. If you know, okay, so two ways to do that. One way is to break it all down, so 2 and 12 and 2 and 6 and 2 and 3, right? And look for those pairs. Square root of 4 is 2. And then we'd have the square root of, those don't have pairs, so it'd be 6. So plus or minus 2 root 6. Or you can also say, I know 24 is 4 times 6. Square root of 4 is 2. And square root of 6. Okay. Number 25, we want to use factoring. Okay, that's x squared is equal to 2x plus 24. Okay, so we first have to get it equal to 0. So we get x squared, subtract your 2x over, subtract your 24 over, equal to 0. And then we can factor x minus 6 and x plus 4, and we set them equal to 0. And I know that x has to either equal 6 or negative 4. Number 31, also want to use factoring. 31, where's that problem? Okay, we got negative 4 plus 9x minus 2x squared equals 0. Okay, so this isn't quite in the right form right away, and usually when we're factoring we want an x squared that's positive. So we can kind of think about, what if we just take everything over the other side? Or what if we just multiply everything by negative 1? Both of them do the same thing. That would be a positive 2x squared. So it'd be a negative 9x. And it'd be a positive 4. Okay. Now we're ready to factor it. So 2x times x gives me the 2x squared. You know, it's going to be a negative times a negative to give me a positive, and add to be negative. And 4 and 1 would give me the negative 8, and negative 1 gives me negative 9. So I set them equal to 0, and I get x equals 1 over 2, and I get x equals 4. Number 32, we want to use graphing method. Okay, so you're going to use Desmos for that. Okay, but we have the problem negative 5 plus 16x minus 3x squared equals 0. And yeah, the beauty with graphing is you don't even need to get it in any certain form. You can just use Desmos and put it in. Okay, when you graph that in Desmos, it looks like this. And your points are 1/3 or 0.333 and 5. So an x is equal to 1/3 and 5. Now, with all these up here, you could also check yourself with this Desmos. You can get this into decimal answers and see if the decimals match up to that. Okay. 37, we want to use the quadratic formula. So 37, we have x squared minus 2x minus 4 equals 0. So once again, we want to make sure it's equal to 0, which it is. Okay, so we can use the quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Okay, that makes that a 2 plus or minus. Okay, 2 squared is 4, b plus 16, b 20. Okay, now we want to take 20 and break it down. So the square root of 20, I'm going to, use 4 and 5. So the square root of 4 is 2, right? It gives you a pair there, and 5 doesn't break down. So we have 2 plus or minus, okay? It would be 2 square root of 5 over 2. And then we know 2 divides into all of these here, so we have 1 plus or minus 1 square root of 5 over 1. Number 39, 2x squared plus 2x equals negative 1. Okay, so there's our problem. And we want to use completing the square. Okay, so to complete this square, we want to divide everything by 2. So I have x squared plus 1x equals negative 1/2. Okay, now I'm ready to complete the square. Half of 1 is 1/2. 1/2 squared is 1/4. Okay, and this here will factor down to be x plus 1/2 squared. 0.5 is fine. 0.25 up there is fine too. This would be negative 1/4 when you combine those together. Okay, get x, take the square root of both sides. So we have x plus 1/2 is equal to plus or minus the square root of negative 1/4. Okay, we know this since it's negative, it's going to be imaginary. And the square root of 1 is 1. The square root of 4 is 2. Okay, and we have to bring this one over too, so it'd be negative, subtract that over. So we have negative 1/2 plus or minus 1/2 I. Number 95. Okay, now we're getting into the inequalities. Okay, so part A. We first want to know where it's equal. So if I use factoring x plus 3, x plus 1, I get x equals negative 3 and negative 1. Okay, so I know that's where it's equal. It's a positive x squared, so it's going to open up. Okay, you can go to Desmos too and make sure you get that. Now we want to know where it is greater than or equal to. Okay, so up here and here is where it's greater, right? The outputs are positive numbers. Down here the outputs are negative numbers. Okay, but here they're positive. So from negative infinity to negative 3, and it says or equal to, so I'm going to include the negative 3 there. And then also from negative 1 all the way through infinity. Okay, for part B, it's the same equation. We want to know where it's less than 0. So we can use the same graph. Where is it less than 0 would be this part right in here, because those are negative outputs, right? So, and it's not or equal to, so we're going to use this. So between negative 3 and negative 1. Number 107. Okay, we want to solve for the t. So we got to get rid of this other stuff. I like to get rid of the fraction first. I'm going to multiply it all by 2. So 2s is equal to gt squared. Divide by the t. Divide by the g. So 2s over g. Okay, and then to get t by itself, remember when you take the square root, don't forget the plus or minus. So there's your answer. And number 112. Volume is equal to 1/3 pi r squared h. Okay, so we're solving for the r. Okay, so I like to multiply to get rid of the fraction. Divide by the pi and the h. And take the square root of both sides. Don't forget the plus or minus. Okay. And then the last page, page 197, we had to do number 17 and then number 28. Okay, so number 17, we have this equation, s of t is equal to negative 16 t squared plus 44t plus 4. Okay, so it's a baseball being hit in the air. Okay, so if you remember this equation, this is the starting height. Okay, so we think about this. We have two variables. We have the time and the height. So it's starting at 4 feet in the air. That's kind of like where a person's hitting it. And it's traveling at 44 feet per second. And this is the gravitational pull. So that equation's given to you here. So 17, how high is a baseball after 1 second? Okay. At 1 second, basically I want to find s of 1. So how do I find s of 1? I just plug the 1 in there. Okay. So negative 16 times 1 squared plus 44 times 1 plus 4. Okay. And you get 32 feet. Okay. So at 1 second, you just plug the 1 in. If I want to know at 2 seconds, okay, I would plug the 2 in. So I know after 1 second, I know the height is up there at 32 feet. Okay. Part B. B asks for the maximum height. Okay, so the maximum height is the vertex, right? So the easy way that we found the vertex back a couple sections was using negative b over 2a. So we have negative b over 2 times a. Okay, and that gives us 1.375. Now, that 1.375 is the x of our vertex, right? So right here, we want to know what the height is, though. So we need to take that and plug it back in here. Okay. So when you plug that back in, you get 34.25. Okay. And that is our answer. That's how tall it is. Part C, I also asked you to say, to find out how long is until it hits the ground. Okay, so when it hits the ground, that's this point right here, right? Okay, so I want to know where my y is a 0. So that's basically this equation that I want to solve. Okay, so I want to solve that equation, and I don't give you a specific way to solve it, so I would say use Desmos. And when you look at Desmos, the graph looks like this. And you probably don't see it going out, it's out of range there, but you're just wanting these points here, right? And this point here was negative 0.088. Okay, since it's negative, time can't be negative, so I know we're not going to use that one. So it has to be this one over here. So 2.838. So it goes in the air. If it's hit 44 feet per second, 4 feet above the ground, it's in the air 2.838 seconds before it hits the ground again. Okay. Number 28. Okay, it says the length of a raised wooden walkway is being constructed through a wetland. The walkway will have the shape of a right triangle with one leg 700 yards longer than the other. So we'll say this one's x. This leg is 700 yards more than that. And the hypotenuse, 100 yards longer than the longer leg. So 100 more than this would be x plus 800. Okay? Find the total length of the walkway, so the total all the way around. Okay, so we're going to use a squared plus b squared equals c squared. Okay, so x plus 700 times x plus 700. So this would be x squared plus x squared plus 700x plus 700x plus 49. Okay, and x squared plus 800x plus 800x plus 64 and 4 zeros. Okay, combining like terms, on this side I have 2x squareds and x squared on that side. I have plus 1400x. This is plus 1600x. Okay, if I get it all equal to 0 to solve, I'm going to subtract that over here. I get x squared. Subtract these over here, minus 200x. And subtract that over there. I get negative 1, 5, and 4 zeros. Okay. Now, once again, I think the easiest way to solve that is to use Desmos, like graphing. So if I don't give you a method, feel free to try to use Desmos to... Okay, so by using Desmos to graph this, the graph looks something like this if you zoom out. The negative one I don't really care about, and the other one is at 500. Okay, so I know that x is equal to 500. So if we know the whole distance around, x, one side is 500. This side would be 500 plus 700 would be 1200. And this is 500 plus 800, which is 1300. So 5 plus would be 3,000. Okay, and this is in yards. Okay, so that is the answers.